can't find it for you.
It's kind of, I think it should be hard, but it's just.
I need to start ranking.
It's an
I
exhibit.
forgot.
It's an exhibit.
All right, so I am, okay, you want, what was it? Y'all, 1, 2, 3.
I mean, I can do it on paper if you don't have it. But I probably want to set up one
Yeah.
paper.
He's in.
Is this the one
That's
where
right.
What?
Have you committed to the cause?
Yeah, I accepted my stock.
This was on.
That's a bit.
It's like, all the time.
1, 2, 3 is what it was?
Yes.
Hey, was anybody not here yesterday that didn't get 1, 2, 3?
No, you're number 6.
Hey, come on, man. Okay, mine is better if I just print out these things.
Yeah.
What is your?
All right, so that I don't forget,
I know.
here is 4, 5, and 6. Okay, so I made a mistake yesterday, as you might have if you looked at your assignment sheet. I was supposed to give you all 6, and that would have made a really long homework assignment because you're supposed to do 15 minutes apiece. So I started rethinking it, and anyway, I'm going to give you a new assignment sheet. So here's what I'm going to do. Instead of starting our test tomorrow, because I was kind of planning initially on doing all 6 problems today, and that wouldn't give me any time to go back and look at the other missing multiple choice problems I didn't get to. I'm redoing it. So I'm going to hand you this assignment sheet in a second. But we're going to do 4, 5, 6 tonight. All right, so our quiz will not start tomorrow on Thursday. It will start on Friday. And then what I'm going to do is I've redone the rest of the year. Instead of doing on this first quiz, instead of doing free response, since you really haven't seen a lot of those, I'm just going to do the multiple choice. Okay, the multiple choice are smaller little nuggets of problems, won't take as brutal a toll. So I'm still, the days we do the free response on Monday and Friday, when we do the multiple choice tests in here, I'm going to hand you the free response to do as homework, just 3 problems each night. And then when we come back, you'll see that as we go over it real quickly. That'll give us an extra day to do something tomorrow, to go over stuff another day. And then the rest of the year will kind of look on pace as it was. So you can take your former assignment sheet and toss it. And here is your here are the problems for tonight. If you would like to recycle, feel free. You don't have to scrunch it into a ball when you do that. That just makes the recycle bin, which is already overflowing, fill up. So here's the first thing.
Do not break the seat.
Never?
No, I have.
Not like it.
I don't want this to fly.
And here is your new assignment sheet. So make sure you're not looking at the old one, guys. If you do, that could get you in trouble as far as not being ready for a test. Although at this point, getting ready is kind of a complicated thing. I think the best thing you guys can do to get really ready for a test or anything is to go back through all those formulas, make sure you know your derivative rules, your integral rules, for all the weird ones, easy ones, whatever. So let me just highlight the differences. If you've already thrown the other one away. So the differences are, instead of starting we're not going to have on this first, it's not going to be a 100-point quiz, it's going to be a 50-pointer. All right, and it will only be based on your 2 multiple choice sections. So instead of doing free response tomorrow, Friday, and then multiple choice Monday, Tuesday, we're just going to go over the free response that we're doing tomorrow, and then we're going to do multiple choice Friday, Monday, and then on Tuesday, when we would have been doing that last quiz, we're going to use Tuesday, Wednesday, and Thursday, and even Friday to go over all of the multiple choice tests that we took, the free response packet we're going to do for homework, That'll give us an extra day to go over it, make it a little bit more relaxed. And then on April 12th, we'll start our first, I don't know, I guess you could call it big test, but our first test that's full length. And we'll do that all week. So we'll test Monday, Tuesday, Wednesday, Thursday. You won't even be here Friday because of the inclement weather day. And then when you come back on Monday, for those of you that are sick at the lake, you can watch the video. For those of you that are here, we can do a Q&A over the free response. And then when you come back on Tuesday, you can just see that. At this point, it kind of is the same. One comment I want to make is I have to go to a doctor's appointment. Well, that won't affect you. So Wednesday will not affect you. That'll be business as usual. Thursday will be business as usual. And then we begin our big test on the 23rd. Okay, now, if for some reason we're not here the 23rd, 26th, 27th, or 28th, you will take a different test. Okay? I have two versions of this exam anyway. One will be for your class, one will be for the other class. And but if you're not here, you're going to take a different version. The downside of that is when we're going over the test on Thursday and Friday, we'll be going over a different test than you. So and that's going to hurt you because you're going to be like, and you're just going to be staring up here at problems you didn't have to struggle through and experience. So I would strongly encourage you to wipe your calendar and be here. And I realize there's things that are unavoidable or things that are just really important to you. That's fine. For those of you that are like, man, I'm dominating already. I'm making fives already. Well, I wouldn't really worry about it. But for those of you that are like, gosh, I'm getting worked over on these quizzes and you need that experience, make sure you come here after school or in the morning and I can give you a copy of the key and you can sit down with your key and look over what you did and ask me questions privately. Y'all with me on that? And then does anybody here know what May 3rd? That's the first day of AP exams. Is there an AP exam in the morning that y'all are going to have May 3rd? Y'all even know? That I don't know, and I don't know what's what. I haven't looked yet. Okay, so if you are on that May 3rd date testing in the morning, again, if you haven't been really doing well on these tests and you need that practice, make sure you come after school. Our test is the next day, but you're going to miss me going over all those questions on that Monday. And I'm telling you, going over them where the improvement happens. So who's an AP Gov in here? Okay, so for those of you whose hands are up, if you're getting 4s and 5s on this test, and that's all you need to get credit at your college, you're probably fine. Most of the time, people don't drop a letter grade. They don't. So if you're fine, great. Maybe you don't even care to come back and look and see what you missed. But if you're getting 2s and 3s or 3s and really low 4s and you're like, crap, man, I need a 4 for my major and so, make sure you come and learn from your mistakes. That's all I'm saying. But that'll be totally up to you for those of you that go. And by the way, I can't post the videos on these secured exams. I picked some non-secured exams on days that I need to do videos. Are you with me? Like I could post this one, but I can't post the one. I'm going to have to pick a new one for the lake day because I can't post some videos. They are secured exams, aren't allowed to leave here. I'm not allowed to put copies online, that kind of stuff. So the big test, I can't video. I mean, I can video, but I can't post it. Or I could, but if I do, I lose my ability to either teach an AP class if I'm caught. So I'm not doing that. Are you with me on that? Okay, so just know that moving forward, you really need to be here because many of the days we go over stuff, posting the video is not a reality. All right? Okay, so we went through problems 1, 2, and 3. We're going to quickly go through that as fast as we can. And then when we're finished, we can go back and look at anything we haven't done yet on the multiple choice questions. So, let me go find it. Cal review. Okay, here's 1, 2, and 3. What? Half does not exist. No?
You could like popcorn it up on the board.
Well, I have a hard copy. It's not as pretty. Let's try it again. Man, you stink. Open. All right. So there's an error opening the document. Let me try through mail. Gmail. Delete. Trash. Test solutions. 1, 2, 3. Okay, here we go. So here's test 1. And let me blow it up a little bit. So on this, I'm sorry, problem number 1. On problem number 1, most people are probably going to get this right. If you don't, learn from your mistakes, okay? So right here, I've got a top function and a bottom function, and all it says is find the area of region R. If they put an R in there, guys, they're not trying to be sneaky. Don't go, oh, wait a minute, this is region R. Some of you did that on the test. I put R in there, and you're like finding a different region. They're literally labeling it for you. So that's R right there. So clearly, for area, I'm going to go what? Top minus bottom from 0 through whatever that is. And you'll notice that I just wrote down the A value. But what might be a better idea if you noticed in the next part, you had to know the Y coordinate to do the problem. So sometimes it's better just to say things like the point 0.76497, comma, what was the other part? 0.552 or whatever. Sometimes it's better to say that's AB or something like that. Or in this case, it would be AK because they called it K or whatever. But sometimes it's better to write the whole point down when you have it. And so that way you don't have to go back and mess with digging it back up if it's gone, okay? So, because like if you have an 84 and you solve that and you go back and do something else, that solution is now gone and you'd have to refine that intersection. Not that it takes forever, but whatever. So anyway, top minus bottom, I got to find that intersection point. When I did, I found that. If I had an Inspire, I would store this. If I have an 84, it's saved as X. And then I just do the integral from, I called it A, from 0 to A of top minus bottom and write it down. You got 1 point for writing the integral correctly. And yes, they do half points, but they never tell us how they do them. So if you'd have written the wrong A value, I'm guessing you would have had a half point there perhaps, but you certainly would have missed your answer. So this was a 2 point. 3 point, because you got a point for A. And a lot of times they say, if you write A here and you use it, as long as you write it somewhere, you'll get that point somewhere from the problem. So anyway, that's part A. That's a 3-point section. Here's part B. It says a horizontal line y equals K is drawn through the intersection. So to give you a quick visual of that, they're saying if a horizontal line y equals K, so that's y equal K, is drawn through that, what would the K be? Well, the K is the Y coordinate at that point that you found, right? So if Y equals K is there, it says, is this area right here the same as that area right there? And if it is or isn't, you have to show why. It doesn't look like it is, but I don't know, it's pretty close when you actually did the math. So how do you find the area of that top region? Top minus bottom, but this time the bottom is K, 0.552. And then you're going to do that again from 0 to A. And then you're going to find the area of the bottom part, which is K minus the bottom. And you have to find that, again, that K value is 0.552. And you're going to do that from 0 to A. So here I go again, 0 to A. That's actually, this is the top part. 0 to A, top minus the K, and then 0 to A, K minus the bottom. And when I looked at those two, they were not equal. And there's other ways you could do it. I mean, you could say this is not equal to half the total because you already found the total, right? So you could say half the total is not this or is not this, and that would work as well. But you got a point for these two integrals and a point for stating that they're not equal. You got no point for acknowledging what K was. But if you didn't get K right, you didn't get the problem right. And then the last problem is a volume question. So they're telling you to take the region R and revolve it around y equals -3. So when you do that, clearly that's going to be a what? A disk washer situation on a horizontal axis. So remember, it's not top minus bottom, it's what? Top minus axis gives you the big radius. So there's top minus the axis, so you can put +3. That gives you the radius. Pi r squared gives you the circle area, right? Give it a little width and do that from 0 to a. That's the what hole. And then the hole would be inner, so it's outer minus axis, and then inner minus axis would be, wait a minute, did I do that backwards?
No, you did it right.
You did it right.
The top equation is 1 minus x cubed.
How was that? That's sine of x squared?
Yeah.
That's weird. Oh, well. Anyway, yes?
Do we have to write units?
No, you don't. If it gave it to you, if it ever gives you the unit, then absolutely do it. If it doesn't give it to you, they won't give you points for that. Y'all with me? And again, you're allowed to round, which would be 0.841, or just truncate. So this is probably like 11.8407 or something like that. Round or just chop, which is truncate. So guys, that's 9 points. Now they used to have this problem every single year, something like this. Maybe they did cross-sectional volume, rotational volume, whatever. They did this every single year. And then the last couple of years, they went, man, it's just too obvious that we're doing that. Let's start giving them weirder volume problems or stranger things, or maybe half volume, half related rates. So they haven't always been just hand spooning feeding you 9-point area problems and volume problems. They don't necessarily do that, but they used to. Now they may come back to that this year, but this is what we really typically know as a class. You got to know your stuff here, because if it is on there, it's 9 points that are just given to you. All right, and that will help you when you're given problems like number 2. Because number 2, a lot of people, when I remember grading this, got hammered. Okay, now you guys are used to this. You guys are used to seeing functions like f as the amount and then f prime as the derivative. And sure enough, they started dropping saying function p is the amount. But then they turned around and gave you function b and d. But b and d are what? Rates. Okay, so if I want what is the rate of change in the population, that's p prime. Because p is the population, the rate of change of population is p prime. And if you think about rates of change in population, by the way, I don't have function p. I don't have it. But if I think about rates of change of populations are functions of births and deaths, right? And there's a birth rate, there's a death rate. So if I just subtract them, that's p prime. And if you didn't get that statement, you were crippled on this problem. You really, which is unfortunate, and that's not very common. Usually they make the questions where one mistake is not going to cost you 9 points, but it does on this problem right here. Yeah.
So for this part of the question, the only thing that mattered in your response was the answer.
Yes, and probably because when they started grading, because notice they don't put the point values when you're taking these tests.
Right.
They probably were like, okay, we were going to make this a 3-pointer, but everybody got hammered on this. Let's make it a 1-pointer. But again, I don't know why, because if you didn't get this part, you didn't get the other parts most likely, except maybe part 3. You could have gotten part 3, I think, or part C. But anyway, so my guess is this is normally a problem like that would normally be for like 2 or 3 points. Like one, they normally give you a point for that statement for saying this, and then a point for the answer. You don't have to say that it's p prime, typically, as long as you acknowledge that that's what you get. Okay. So anyway, but you probably did need to acknowledge that you plugged the 0 in there. So at a time of 0, plug it in there and get your 750. But in this case, they just gave you 1 point. Next part. So if p prime is this, and then they ask you about population, how do I turn a p prime back into a p?
Integral.
I integrate it. So literally, I have to integrate that. But if I integrate the rate of change of the population, I do get the amount of change, right? Or the change in the amount, but that's not the final amount. So what do I have to do? I integrate to find out how the population changed, and then what do I add that to? The initial amount, which they told you at time 0 there were 100 payments. So on this one, you got a point for acknowledging the integral from 0 to 40 and having that difference. And then you got a point for that answer. And that's not typical. Normally what they do is they go, hey, you get a point for remembering to add on 100,000. I think I said 100,000. And then you get a point for finding this value and a point for the final value. But that's not the way they worded it in their grading document.
If you had set it, could you have set it up as two different integrals? Like the integral of the first minus the integral of the second?
Sure. Sure, yeah. Y'all with me on that? But I would have just plugged this in my calculator. I would have had that already in my calculator from doing this one probably. And I would have just said the integral of y1 minus y2 or f1 minus f2 from 0 to 40. And it would have just spit that out and I would have picked in that 100,000. All right, so again, if you didn't have the b minus d as a rate, then you probably didn't know to integrate the rate to get the change in the amount. All right, this is a very missed question. I gave this on the big test to my students like, I don't know, a zillion years ago, 6 or 7 years ago. And I remember as a class, they got hammered on this. But they made it up on some other easier questions too. So if you did well on this, that's really great at this point in the game. I mean, really great. Because I thought this was a trickier question for my students. And then part D, I think. So parts. Two things about average. You've learned average rate of change and you've learned average value. So if you look at it as average rate of change of population, we've learned that the average rate of change is the slope from beginning to end, right? So the slope from beginning to end would be the p, the population at the end, minus the population at the beginning. That's like y minus y over x minus x. Problem is, I don't have a population function. So I'm not going to look at it as average rate of change of p. I'm going to look at it as average rate of change. And what is the rate of change of p? P prime. So I'm looking at it as average value. I'm looking at all of this as a value. And the value is the p prime. And this is p prime. Are you seeing it? So I went average value. And you remember, average of anything is that thing right there from beginning to end over beginning minus, or end minus beginning. So I did average the integral of p prime, which happens to be this from part A, from 0 to 40 over 40 minus 0. And they gave you 1 point for an answer only on this. So I really think they were looking at this and like, all right, we screwed these kids with this problem. There was so much carryover. Let's save them in part D. Now, again, you didn't get saved in part D because, again, if you didn't know that B minus D was the P prime, you missed this again. Actually, I'm thinking of a different problem when I said save. So my point on this problem, this was just a tough question if you did not get that initial statement. So this question said, find the minimum population and the maximum population, not relative, but the min or the max. And how do you find mins and maxes?
Graphic.
You could, but you don't get credit for that. You'll get credit for an answer, but you won't get credit for work and stuff like that. Critical numbers and endpoints, okay? So we know endpoints are 0 to 40 because we've been talking about that. Is there a critical number in there? So here's what I thought. If I want to know if I want to know max on population, I want to take the derivative of the population, which I already know is this, right? Set it equal to 0. So either do that function minus that function, graph it and see where it intersects, or graph the two of them. You could set them equal to each other, graph the two of them and see, graph that minus that and see where there's a 0, or set them equal to each other and see where they intersect. But you're graphing it. And when you do that, you see it crosses at 34.657 if you're finding the 0. And then that's the critical number. And I've just checked P0, P that, and P40. And this is tricky. P0, I knew that's initial amount. P40, I found on a prior question. So all I got to do is find this the same way I found P40. Look back at how I found P40. Remember? P40, I integrated from 0 to 40 plus the initial. Well, all I'm doing now is integrating from 0 to 34.657 and then adding the initial. So if I was able to do P40, I should be able to do this. But you got 1 point for making that statement or that statement, and then 1 point for the answers. And I got to argue this. To me, this is one of the Anybody get 7 points or better on this? Anybody get 4 points or better? Anybody 0 to 3? Yeah, honestly, that's actually pretty good results for 5 years ago. I don't think we even had people getting 7 and 9s on this. Maybe one guy, you know. But anyway, that's pretty great if you did. That's one of the harder problems to get points on in my experience, because if you made that initial error, you got killed. All right, number three, back to something a little bit more doable. In my opinion, of course, that's all relative. All right, so what did I give you a chart of? Time and what? The derivative of W. And what is W?
Volume of water.
So W is volume. So what would the derivative of W be?
The rate of
The
change
rate
of
that the volume is changing, or the rate of change in the volume, okay? So this is rate of change, not amount. Make sure you get that, all right? So this is the times, and this is the rate of change. You got to focus on those little details. I know one little shouldn't make that much difference, but it does. Now, what do they give you in the problem? They're saying at time 30, the reservoir has 125 gigaliters. So that's giving you a point on what function? The W or the W prime? The W. So that's a W point. Remember it. These kind of points come back to the question. Maybe in part D, maybe in part C. You've got to make sure you remember this. Yes?
Why is it gigaliters? Because it says the volume is in gigaliters. So would it be gigaliters?
Throw out the question.
Yeah, liters is already in the volume.
Oh, you're right. That's my mistake. But again, well, on this one, they didn't give you a point for that, but you're right. That's just my error on that. Yeah, a liter is volume. You're right. Yeah, that's me. If you look at their key, which I don't have pulled up, it probably just says 126. They didn't give a point for the unit on that, although often they do, but they did not. But the good, excellent point. Let's read. It says, use the tangent line approximation to W at time 30. I know something about 30, right? To predict the volume of water in gigaliters at time equals 32. So can I find a tangent line approximation to W? What do I need to know about W?
It's equation.
I need to know the equation, but what do I need to be able to get that equation for W? I need a point at 30, got it. And I need a slope at 30, I've got it. Y'all seeing that? So all I gotta do is take that slope and that point, plug it in an equation, and I've got, now they only gave you 1 point on this, but very often they'll give you 1 point for that. And then this question then said, I don't just want the tangent line approximation, I want to use it to approximate what would happen at 32. So what do? Plug the 32 in there and do the math carefully. This is a non-calculated problem, so make sure you're careful, right? And you got 126. You got 1 point on this particular problem. But very often that's a 2 point. All right, so moving on. And notice how if you didn't get that right, you're still fine on the rest of this stuff. All right, now, using a left Ramon sum with 3 subintervals indicated by the data in the table. So we're doing a left Ramon, right? Approximate the integral from 0 to 30 of W prime. Well, that's no big deal, right? So the integral from 0 to 30 of W prime is, and what do? Looking at this. Base, which is 10, times what? Left, 0.6. Base, which is 12, times left, 0.7. Base, which is 8, times left, which is 1. You get 1 point for writing that out, usually, and then you get 1 point for the answer. And that's how they did it in this one. Writing that out and getting your answer. And again, you do not have a calculator on question number 3. What is this? Just 2 or 3? No, it's just 2. You do have a calculator on these. Sorry.
That's 3. This is 3.
No, we don't have.
It says no.
Oh, this is 3. Sorry. So on question number 3, you don't have a calculator. So you just be really careful with the decimals, right? To make sure you don't miss because of that. Now, then it says, use this approximation to estimate the volume in the reservoir at time 0. So what did I just find? A lot of people miss this. They think, oh, that's it. That's not, what is that?
That's the change.
That's the change in the volume, right? When you integrate a rate, you get a change in the amount. So the volume changed 22.4. But what did I start with? 125. Now, most people don't write it like this. Most people write this. They write the integral from 0 to 30, and they write is W30 minus W0. But I'm looking for W30. I'm sorry, I'm looking for W0. So since I'm looking for W0 right here, I'm going to add that and subtract that. That's why you see W30 minus the integral on this one, okay? But all I did was set up the fundamental theorem and then solve for this. I just didn't show my work. Are you seeing that? So sometimes, a lot of times we're finding the ending amount, but this time we found the beginning amount. And why? Because I didn't know the beginning amount. I knew the ending. So sometimes I'll flip it around on you and make you solve for one or the other. Does that make sense? And this right here was 1 point right here. So 2 points, even if you missed that last part, at least you were able to get 2 points. And again, if you can get 2/3 of your points, you're well on your way to a 5. It'll be tight, but you'll have it. All right, right here, letter C. Explain why there must be at least one time other than t equals 10 where the derivative of w is 0.7. Now look back at the chart. Now clearly at 10, the derivative is 0.7. How do I know there's another place that's 0.7? The intermediate value theorem. Now if you were looking at the key, you saw that. But if you didn't remember the intermediate value theorem, you would have to make a statement like, well, what did it say about this? It said it was differentiable. And if it's differentiable, what does that mean? It's continuous. You could say something, well, on a continuous function between time 22 and 30, I'm going to have to go through every y value on my way from 1 to 0.5. Therefore, I would hit 0.7. But guess what I just said? I just quoted the intermediate value theorem. Now, I usually double quote stuff just because I'm a little unsure of what the readers might want. So a lot of times I'll just say, oh, I know this because the intermediate value theorem guarantees, and I might state those 2 points like, hey, the derivative at 22 was 1, the derivative at 30 was 0.5. Intermediate value theorem guarantees I'm going to go through every value. So sometimes I kind of overstate it, but really these readers are reading pretty quickly. They see IBT and they're probably going to jump all over it. All right? Or you might say intermediate value theorem guarantees every y value on this interval 22 to 30 between 1 and 0.5. But whatever, that was 2 points, and they weren't really very clear. They just said 2 points for making a statement about that. And then lastly, this problem sadly cost a lot of people, even though it was pretty doable. It said if that's my area equation, all right, it says find the instantaneous rate of change of A. And a lot of people did this for area. They went, oh, A prime equals, and they multiplied 2/3 by 0.3, copied down the W and subtracted 1 and got negative 1/3, and they stopped there. But what do we know when we take a derivative? We're always doing what? dAdt, dW dt. All right, so if you're taking a derivative with respect to time, and you can see that there in WT, this needs to be dA dt, and this needs to be times dW dt. And you see that right here. Y'all tracking with me? Mm-hmm. Now at that point, you're like, well, how do I find dA? That's the derivative. Write that. Don't plug jack in there, right? That's 0.1. I mean, that's 1 point. Then you got a point for writing the actual value. Notice how I'm labeling it at time 30. Now, how am I going to find the W at time 30? They gave me, well, it's not in the table. The W at time 30 was given in part A, remember? There's the W at time 30, right? So plug 125 in. Now, how do I find the dW dt at 30? That's in the table, because that's the slope of W.
That's true.
Are you following me? D loves, part D and C love to pull stuff from part A. It's like just as you wander enough away from it, they pull you back in that way. So make sure you got a point for even plugging those in, even if you did the integral incorrectly, or the derivative incorrectly. And then it's just a matter of crunching numbers and being careful. And that would have been that was 3 points for your answer, whether you wrote it as a decimal or a fraction. And that was the end of the calculator part. All right, and then here is, oh, and that's a non-calculator part. Dang, what's wrong? So anyway, be really careful about this stuff. A lot of people do a little bit better if they struggle with the math by changing decimals like 0.3 to 0.3 and 0.5 to 0.5. And then to them, it's a little easier to cancel stuff. Y'all with me? Okay, so don't pack up yet. I want to go back and look at, see if it's giving me any more ability to look. Okay, what did we get to on part A? Do y'all remember?
20.
We had the
Or
last,
21.
Did we do that one?
like,
No.
we did,
Did we do that one?
We were in the middle of that one.
Okay, so when you look at that, it's screaming second fundamental theorem, right? When you see this, to me, it's screaming second fundamental because you see dx of an integral. So plug the 2x in and don't forget to take the derivative of the 2x. That's the part that people miss. They forget the times 2 and they pick b instead of d. So be careful about that. And 21 is this integral right here. And it says the function, what is the value for the integral from 0 to 7? What are they asking you for here? Area. So be careful about area right here. If you don't know a trapezoidal, if you don't know how to do 1/2 or do base times half of the heights, right? If you don't see that, see base times the average of the heights for that. And just think about it as a 2 blocks in a triangle. Whatever, do what you got to do. That's clearly 2 times 2. Also, notice your units. Sometimes this is 1, 2, 3. Sometimes this is 5, 10, 20. So be careful on that kind of stuff. This is a base times height times a half. And then this, because it's below and I'm going that way, it's negative. And remember, if I change this from the integral from 7 to 0, everything on top is negative, everything on bottom is positive, right? So anyway, add it up and you get a 6. Hopefully that's not a big deal, if you remember that. 22, the function f is continuous. It says, and the average rate of change on the closed interval is -3/2. For values from 6 to 9, there is no value of c where the derivative is -3/2. Now, wait a minute. They just said that the average rate of change, right, is -3/2. There's average rate of change. Then they said there is no value of c. But we learned on the mean value theorem that the derivative has to be, the instantaneous rate of change has to be equal to the average rate of change. So if they tell you that there's not, that's not true, what must that mean? The conditions weren't met. And what are your conditions?
differentiable and open.
Continuous on a closed and differentiable on an open. And when you look down here, that's the only thing close, right? Differentiable on the open. So it must not be differentiable there. Because you could look at all this other stuff and whether it makes sense or not, that's what's been broken here. Now you might look at that and go, man, I didn't even think about mean value theorem. Remember, mean value theorem, average rate of change is equal to instantaneous rate of change. Average rate of change is equal to instantaneous rate of change. So if it's not, one of those two rules are broken. Okay? 23, let f be a function defined by this. If g is the inverse, remember the inverse stuff? Find the derivative of the inverse at 1. Now, remember this stuff? Yes, no?
No.
So the derivative of the inverse of g, right? That's like saying right here. Saying the derivative of g is like saying the derivative of the inverse is equal to the derivative of the function flipped, but not at the x, at the y that goes with that x. So what you have to do is go, all right, if I can't find the inverse, which I can't right here, or can I? All right. Yeah, if I can't find the inverse, because think about it, if I replace this y with an x, and that with a y, you're gonna have trouble solving, aren't you? Aren't you? So what I do is I go, well, if this is the inverse, just unsolved, I want the inverse value at a 1, right? That's the inverse's value at a 1. So if that's the case, I'm saying what value of y here would give me 1? And I think you can clearly see that y, when y is what?
0.
And you're just guessing and checking. Guess 0, guess 1 and -1, guess 2 and -2. You'll find it pretty quickly. So when y is 0, that's true. So that means that if the y on the inverse is 0, then I'm going to use 0 here. So the derivative of the inverse right here is equal to the derivative of the original function, but on the bottom, but not at x, at the y that would go with that x. Are you seeing that? A lot of people right now look at, who's seeing this? Okay, a lot of people see it and they go, no, I got that, I remember that, I got it. And a lot of people are like, okay, I didn't get it then, I'm not getting it now, I'm never gonna get it. That may be the case. We'll go over it a number of other times. Hopefully you will, but if you don't, sometimes you just gotta cut bait, and focus on what you can get. So once you do that, you do have to go back and take the derivative of the function, which gives me this, and then I just plug a 0 in there and I get 2 plus 1. So 1/3. All right? But we'll go back over that a number of times. I've got good notes on that if you want to go back through the book. You can see a lot of examples on that. And sometimes they give you a chart too, but not this time. 24, the function g is given by that equation. What is the absolute min? This is going old school back to the beginning. How do you find absolute mins? Critical numbers and endpoints? Do what? And then plug them all in? So first thing I do is got to find critical numbers. So I take the derivative and get this, set it equal to 0. I like factoring or dividing stuff out. I divided a 6 out, made it easier to factor. That's actually one of the harder factoring problems I see. Most of the time I don't even have a number up front, but it's still not that bad, right? And you can do quadratic formula to find those values too. And once you get those, check those two and the endpoints, which are -2 and 1. Make sure you don't check those if they're not in that interval, right? So if you got -3.5, -3 comma 1/2 is your answer. Don't check -3, all right? It's not in the interval, so don't look at it. But all of these were in that interval, so I'm taking all these, plugging them back in, which is a little tedious on the non-calculator part. Take your time, and you can see that the absolute min was -7. All right, number 25. Which of the following is the solution to that? Oh, we did number 25 in class because you asked about it, right? And then 26, although we probably didn't get through finishing it, I think we got down to about right here. And you can see me plugging in the 0 and the ln4 for x and y to find c. C was a little tricky to find there. C would have probably been a little easier to find if I maybe found it up here. But when I tried to find it here, you can see I had to go back and E both sides to get to here. But then I got C was 5, so I plugged the C back in, and then I had to negate both sides. So probably would have found C maybe a little bit better if I found it up top, but I can still do it there. All right, 26. Which of the following is an antiderivative of that function? What's an antiderivative? An integral. So I've got to integrate this function. So I integrate that dx. Clearly that's not working for me. U sub stinks, so guess and check. Oh, yeah, that was ugly because I don't have the rules to do this, do I?
No.
I can try all day and not do it, but I do have answers, right? So if this is the antiderivative, what should I be able to do to these to check and see if it's the equal to that? Take the derivative of them. Does that make sense? Yes, no?
Yeah.
So if I take each of these and start running the derivatives and checking them, 1, A, B, C, D, nothing worked, but when I finally got to D, it worked. Which is pretty, actually to E, it worked. That was pretty dirty of them. That's checking your knowledge of if an antiderivative of something is blah, then the derivative of the blah would be the antiderivative. Sorry.
Blah.
Would get you back to where you began. Anyway, but yeah, the derivative of that would get you back to. And this requires you to know fundamental theorem. Number 2, right? Take the derivative of that one. 27, height of an object suspended from a spring is given by this. What is the average height? Blah. What is the average blah? Right? So if that's height, average height is integral of height, 0 to 2, 2 minus 0. Don't even think about it, guys. All right? So now if you didn't get it after doing that because your U substitution abilities are terrible or your integrating abilities are a little sketchy at this point, that I understand. But please know that the average anything is the integral of that thing from a to b over b minus a. Now, how do you integrate that thing? Well, the 16 is pretty easy, right? 16t. So I've got that. But this requires a what? A u substitution. So if u is that, then du is pi over 4 dt. So I need to take a pi over 4 dt, which means I got to put a what? A 4 over pi in there. So that's why I ended up with a 4 over pi in the end. And then the integral of cosine is sine of u, plug the u back in, and do that whole thing from 0 to 2.
What did you do with your pi over 4? Oh, never mind.
Yeah, the pi over 4 ended up being my du, right?
Yeah.
So you can see I didn't show all that math, but
Yeah.
whatever. And at this point, just make sure you plug the 2 in and plug the 0 in and be careful. And know your unit circle values like sine of a half a pi and sine of 0 and that kind of stuff. So pretty ugly answer here, but that's pretty common to see a couple uglier problems like that. And then the last one, I believe, says the function f is defined by sine x plus cosine x. What's the x coordinate of the point of inflection where the graph changes from concave up to concave down to concave up? So what am I going to need to do to find that? That point of inflection, that's where the second derivative is 0 or d and e. So I take the first derivative and get that. Then I take the derivative of that and get that. I set it equal to 0. And this requires you to know some stuff. When would negative sine x be equal to cosine x? And you don't have a calculator. Well, I know from trig and stuff like that, sine x and cosine x occur, they're equal at like pi over 4, right? I mean, 3 pi over 4, that kind of stuff. So I would just be guessing pi over 4 and 3 pi over 4, and I check those values and I see that those two exist. But now I got to make sure that the concavity right there is, so I got 3 pi over 4 and 7 pi over 4, I got to check values in between. And when I do that, I see it went concave down to concave up to 3 pi over 4.
We still have 2 on the other test.
Yeah, we're out of time. Which ones were they?
The last 2.
Last two? 91? F is continuous. If the function f is continuous and the integral from 0 to 6, what's the value of x times that? I chose to do a big u substitution. And when I did that, I got the integral from 1 to 3 f of u 1/2. And this said 0 to 8. Oh, I got that. But remember, you have to change those values. So when I change those values by plugging them back in for x, look, that was my integral. So I took half of that 6. Hey, we're going to have time tomorrow, and we can go back through this one and the next one.
I didn't realize. Yeah, surprisingly.
So, man,
So. It's a rainy day.
yeah, it
The
is.
second period, it was like pouring.
Yeah, it was dumping. It's really been perfect. I put 4 pallets of sod down in my backyard. I didn't have water.
Oh, oh.
How's it going, guys?
It's a very good one. I got a lot of snipes.
You got the QC. Okay, those are a lot of things.
I actually, I would.